Okay, another video. This one we're going to talk about trig identities and then your angle formulas, right? So this is what the angle formulas was a big part. It came from your yellow sheet. There's going to be 3 or 4 questions about this on your exam. So make sure that you write something down on your pink sheet about angle formulas. Okay, so trig identities, right? There aren't very many things we can do with trig identities. We just need to know basically the reciprocal identities. So like you need to know that the cosecant is 1 over the sine, right? That's an identity. The secant is 1 over the cosine, right? Things like that. We need to know the tan is the sine over the cosine, right? That's a pretty nice identity to have. And all the reciprocals. So the cotan is cosine over sine, right? That's a reciprocal. Those ones are the basic ones that you should know, right? And be able to see. Whenever you see a cosecant, you can replace that with 1 over sine as we're trying to simplify. Because our number one strategy is write all terms in write all in terms of sine and cosine. Okay, so that's our number one strategy when we are simplifying these identities. Take your cosecants, your secants, your tangents, and write them all as sine and cosines. Okay. Now the other ones that are important are your Pythagorean identities. Cosine squared plus sine squared equals 1. Right? That is one of our main Pythagorean identities that we use in courses other than just Precal. So you use that in calculus, AB, and BC. So that's really the important one to know, and all of its manipulations. So sine squared equals 1 minus cosine squared, right? That is a manipulation of this equation. And cosine squared equals 1 minus sine squared. All right, so those are manipulations when you solve this one. We subtract cosine over here, or we subtract sine. So those are the ones that you need to know. Maybe not the secant squared and the tangent squared ones. Those ones are kind of obscure, and they are not used as often. Okay, but remember, this is replacing. You are replacing or you are substituting in order to simplify down to one trig word. Okay, so then let's talk about our angle formulas. Right, there's a formula for all of that. So if we were going to find something like the sine at 75, well, 75 degrees is not a unit circle angle. Okay, but we do know a couple of them. 45 plus 30, those are both unit circle angles. Okay, so 45 plus 30, that's the same thing as 75, and there's a formula for this. Okay, so the formula goes the sine at 45 times the cosine at 30 plus the cosine at 45 times the sine at 30. Right? This is the formula from your yellow sheet that I wrote down. So I'm replacing A. This is my A angle or alpha, and this is my B angle, and that's the formula. Okay, so now I would go to my unit circle. The sine at 45 is root 2 over 2. Right? So I replace sine 45 with root 2 over 2. The cosine at 30 is root 3 over 2. Right? This is from my unit circle. And then the cosine at 45 is root 2 over 2. And the sine at 30 is 1/2. Okay? This is how we use the formula. You split your given angle into 2 from the unit circle. Right? These 2 angles have to be from the unit circle. Both of these, 45 and 30. And then you use the formula. So this is the formula specifically for the sine of A plus B. Now it's just a matter of doing our fractional multiplication. So we do top times top, and we do bottom times bottom. Okay, and then top times top and bottom times bottom. Fractional multiplication. Root 2 times root 3 is root 6. Over 2 times 2 is 4. Root 2 times 1 is root 2 over 2 times 2 is 4. And since these both have the same denominator, I can add / not add my numerators together. We can't add root 6 and root 2. Those are not the same radical, so we cannot actually add them together. So we write them next to each other with a plus symbol. And then you put it over 4 because you have the same denominator. And so this is how we use our formulas. When we have an angle, right? So if we have an angle that we're given, we break those into 2 unit circle angles, and then we can use their unit circle values. Okay, now what if we don't have a unit circle angle? What if I know that the cosine of an angle is, I don't know. Let's see if I can use a Pythagorean one, 24 over 25. Okay, and we also know that that angle is between 3 pi over 2 and 2 pi. Okay? So we need to know that this is talking about a quadrant. In fact, it's talking about the 4th quadrant. Okay? The 4th quadrant. So when we draw our triangle, we're going to draw it looking like this in the 4th quadrant, where this is our angle. Cosine is the x over the hypotenuse, which means our x value is 24 and your hypotenuse is 25. And when we use the Pythagorean theorem, we come up with a calculation for your y value, right? We can find this side, and that's going to be -7. It's negative because we're in the 4th quadrant. Okay, so now that I have my triangle, I can find out any one of my things. So let's just do for fun. Let's do the tangent half angle. Okay, so this is a formula. There's a formula for this. And the formula I'm going to use is 1 minus cosine of the angle divided by the sine of the angle. Okay? So these cosines, this cosine comes from my triangle, right? Cosine is a ratio of the x value to your hypotenuse. So I'm going to replace cosine with 24 over 25, the adjacent over the hypotenuse, divided by my sine. There's a ratio for sine. Sine is the y value over the hypotenuse. So that's -7 over 25, right? Because my y value is negative. And now I have to simplify this equation. So I'm going to change my 1 to be 25 over 25. That way I can do this subtraction in my numerator. They have to have the same denominators in order to subtract them. So now that I've done that, 25 minus 24 is 1 over 25, and I still have -7 over 25 in my denominator. Well, both of these are divided by 25, so I can essentially divide those out. So my final answer would be -1 over 7. Okay? The quadrant matters because the sign of that value in that quadrant matters. Okay, so make sure you have all of your formulas written down, because you need to have your formulas in order to plug in the right trig values. Okay, that's all. Goodbye.